Data and Methodology, Part 4, Margins of Error. All of the BRFSS and Medicare indicators are estimated from sample data, and because of this, they're subject to sampling variation. We have computed margins of errors for all of our estimates and distinguished those for which we are 95% confident that they're different from their respective state average rates. For example, we may report that 60% of older persons in a community reported they received a flu shot last year, with a margin of error of plus or minus 5 percentage points, meaning the 95% confidence interval would range from 55% to 65%. What this actually means is if we repeatedly estimated the rate of flu shots with different samples, the true percentage of older community residents reporting a flu shot should lie within the plus or minus 5 percentage point margins of error in 95% of those repeated samples. The margins of error seem to vary among indicators and among communities. That's true. What factors contribute to these differences? Well, since most of our healthy aging indicators are measured as percentages, the main factor influencing the size of the margins of error are the sample sizes of the estimation samples. The next slide illustrates how margins of error vary with sample size for the same estimate of 50%. Larger estimation samples will produce estimates with smaller margins of error. For example, an estimate of 50% derived from a sample of 96 will have a margin of error of plus or minus 10 percentage points. The 95% confidence interval will range from 40% to 60%. An estimate of 50% derived from a much larger sample of 2,401 will have a margin of error of only plus or minus 2 percentage points, producing a 95% confidence interval ranging from 48% to 52%. This graph shows how margins of error vary with sample size. The message is basically the same as the previous slide. As sample size increases, margins of error get proportionately smaller. Some points to consider about the margins of errors for healthy aging indicators. First of all, you'll find that the margins of error for indicators estimated from the CMS data are generally smaller than those estimated from BRFSS data. This is because the community samples of the MBSF data are generally much larger than the BRFSS samples. It was noted earlier that we have records for 100% of all aged Medicare beneficiaries, even though they're not all included in the estimation samples. Another point is that the margins of error for state estimates of indicators are generally much, much smaller than those of community estimates. And this is because the state estimation samples are naturally much larger, not surprisingly, than those for any single community. We distinguish those community estimates that are statistically different from state average rates with a capital B for better, a capital W for worse, or an asterisk, simply meaning different. And we use a simple conservative rule of thumb. We require that the margins of error for the community rate and for the state rate do not overlap in order to conclude statistical significance. This is graphically shown in this last slide. The top portion of the slide shows a rather poorly drawn example of two 95% confidence intervals, the left-hand side being a tighter confidence interval for a state estimate, the curve in blue showing the 95% confidence interval for a community rate. And the top portion, they don't overlap, and we would conclude that the community rate is greater than the state rate. The bottom portion of the slide, we show that the 95% confidence intervals overlap, and we would conclude that there's no statistical difference between the community and the state rate. The end of part 4. Thank you.